Welcome, everybody, to our Bovaer Canada webinar today. Thank you so much for joining us. And this call is taking place live, so these presentations are happening live. There is a Q&A button on the top if you see the question mark where you can ask questions at any point of the presentation. We will be discussing all those questions at the end when the speakers are done. This call is also being recorded, so if there's any questions that are of a private nature you prefer not to share with all the participants, then we ask that you contact either your Canada rep or the speakers after the webinar. We will share that contact information in case you're not familiar with those names and with those emails at the end of the presentation. The recording of this webinar will be shared when it ends with all registered participants. So with that, I want to present our two speakers today. First, we have Mark Ben Newland, and Mark has been working on the Bovaer business for about over 8 years now, and he is globally responsible for Bovaer. We also have Mike Kinderman, and Mike has been working on the project for over 15 years. He is the inventor of Bovaer. So very happy to have these two great speakers and really the experts in Bovaer today. And with that, I'm going to hand it off to Mark.
Good, thank you, and welcome everybody. Today we'll try to summarize 15 years in 1 hour. So we'll do our best. I'm sure there's plenty of questions. We will speak through it relatively quickly. But at the end also allow for the opportunity to ask those questions. And happy to take any questions offline afterwards as well. So let us get started there. Just a short word on dsm-firmenich. Some of you might have heard about dsm-firmenich. I hope many of you have heard about dsm-firmenich. In essence, it's a large global health, nutrition, and beauty company. We are with 30,000 other talented colleagues, more than 150 years of history, and to put it in Canadian dollars, probably somewhere around $16 to $17 billion in sales, with a totally global footprint. So 1/3 of our revenues in the Americas, 1/3 in Europe, and 1/3 in Asia. So truly global in that sense. What binds some of us all together actually is our R&D and science related activities and capabilities, globally present in many different countries with R&D capabilities, but also about 700 million a year that goes into R&D and bringing the latest innovations to our business in that sense. If we look specifically at the businesses which are more represented today, we have 4 businesses in total, but 3 have relevance to the dairy and or the beef sector. One is animal nutrition and health. That speaks for itself. Basically, make sure that their cows are healthy, are poultry producing properly, the swine as well business. The second business is related to human nutrition and care, and the last one, taste, texture, and health. Both of these are mostly the dairy segment operating, so think about infant nutrition, but also think about enzymes and cultures for cheese or dairy yogurt production, and many other things in between. And then the last business we have is related to flavors, related to fragrances. Sorry for my English there, but of course that doesn't really matter as we speak to cow feed and then Bovaer emissions today. Why are we even looking at Bovaer, and why are we even looking at methane reductions as a whole? So the planet has already warmed up by 1.3 degrees, which is quite significant, right? As part of the Paris Agreement, we're trying to stay below 1.5, so there's about 0.2 degrees left, which is very, very little. This is also what was realized at COP already many times, but specifically 2 years ago in Glasgow. And people said, okay, what can we do to actually avoid warming and avoid going over that tipping point of the 1.5 degrees? One of the key things that was identified there was methane. And the reason for that is that methane is a greenhouse gas, just similar to CO2, but there's a much higher warming potential. So if you increase your methane production temperatures go up much more quickly. Now, the benefit is also the inverse. So if you reduce methane emissions rapidly, you actually see the benefit very quickly. So it's estimated that if you reduce global methane emissions by 30% across sectors, we could actually avoid or eliminate 0.2 degrees of warming already by 2050. Now, 0.2 doesn't sound like a lot, but if we put that in the perspective of we are at 1.3 degrees and we want to stay below 1.5, 0.2 is enormous. And this is also the reasons why many countries, or this now signed by 155 countries. We also see the first dairy companies, for example, starting to align their goals and ambitions with this. So it started off with Danone, who now not only reports in CO2, but also reports specifically on methane. At the last COP at the UN Climate Conference in Dubai, a number of companies, including Nestle, Bell, Heinz, Kraft, and a few others, announced that they will start reporting as of this year specifically on methane and actually also demonstrating roadmaps. So it's quite an important topic. It will increase in importance as we go towards 2030. And given that cows actually produce quite a bit of methane, this is one of the areas where, of course, in agricultural communities, there will be a focus on, right? Next to oil and gas is another big sector for methane emissions. Also, those will feel the pressure to reduce that emission. Now, let me hand over to Mike to just walk us through some of the basics around Bovaer. How does it work? What is it, etc.? But maybe one word from my side before I do so. Where does the name come from? So Bovaer is actually the combination of bovine and air, spelled slightly more creatively, so we don't sound like an airline. But if you now know what the roots are, it's much easier to remember. And with that, handing it over to Mike.
Thank you. Let me quickly share then also the slides on my side and tell me if it works as a, oops. I hope you see the presentation mode now. Warm welcome from my side. Let me guide you a bit through the development, through the scientific development of Bovaer. So cows make methane. That's probably doesn't require any further discussion here in this audience, because you know much more about cows than I do. Methane traps heat. Mark mentioned that methane is trapping heat between 30 or 84 times more than CO2. And at the same time, methane gets destroyed faster than CO2 by natural processes in the atmosphere. And in this way, methane is really our fastest and best way to reduce global warming and climate change on the short term. And this is, of course, an enormous potential that you have also in your hands, because ruminants are producing a substantial amount of methane, and reducing this has an immediate and measurable effect on global warming and climate change. Bovaer reduces methane. So the questions that we always get is, how much Bovaer do you need to feed to a cow? So the scientific answer is 1 to 1.5 grams per animal per day. To make it more tangible, we say 1/4 of a teaspoon of Bovaer mixed in the feed of the cow will reduce methane by, and you see the numbers on the more right side, we say on average 45% in beef, but we also, you see later, we have much higher numbers. And also we say 30% on average in dairy cows. It takes effect immediately. And when I say, oh, very fast, so you don't need to feed this for weeks until you see an effect. And we have beautiful data where you see within 30 minutes, when you feed it, methane goes down to the reduction level, and it stays down as long as you feed Bovaer. And then on the right-hand side, we went through all the registration process. So a lot of scrutiny on this product, and it's proven safe for consumers, for the animals, and it's also good for our planet. How it works. Of course, this is a chapter where I'd love to talk hours about it, because that's how it was developed. But the short version is it inhibits one of the enzymes that is responsible for the biological pathway in a specific set of microorganisms in the rumen, and it reduces the activity of this enzyme to be able to produce and release methane. And the effect then on the large scale is that the animal burps out 30 or 40 or 50% less methane. So it's very easy to implement and very easy to use. And we started this project from a scientific perspective during 2009 and started to run then in 2010, 11, and 12 the first feeding trials. The first one was in sheep in Europe, and then we moved very quickly to Canada. And if Karen Bushman is on this call, she was one of the first working with us in Canada on Bovaer. The numbers that you see here make us really proud. You see the number of trials that we have done in the different regions. And next to this number, you see first how much we did in dairy, in beef, and in calf, and in sheep, which gives an indication that Bovaer works in all ruminants. So whoever is a ruminant, you can feed Bovaer. And you also see the number of methane reduction in percentage that we achieved in the different region. And we will explain later why the numbers are different. Now we are in a situation where we understand exact the biology, what drives these numbers, and we can predict them very precisely. So 63 trials already in Europe, and you see also below this blue ribbon the commercial collaborations that have been made public over the time. And I'm sure Mark will elaborate on this in the second part of his talk. And then North America, 16 trials very early on in Alberta, Canada, and also in the US, 8 beef and 8 dairy trials, and methane reduction up to 82%. The strategic partnership that has been made public in the US with Elanco, I think you are aware of it. In Latin America, we have 8 trials, 5 beef and 3 dairy trials, up to 55% methane reduction. And in Oceania, numbers again higher in terms of number of trials, 15 beef, 6 dairy, and 6 calf trials, and up to 90% methane reduction. And also here you see our commercial partners depicted below. Interesting that also you see labels of a supermarket chain that are getting interested in working with us on Bovaer. It's over 100 trials in 21 countries, so it's really a global product. It works in all feeding systems and in all regions. And we are specifically proud of the number that you see below, 80,000 tons of CO2 equivalents already saved. And this is a number that we need constantly update. So I think as of today, this number is already higher because Bovaer is used in several regions in the world. On the mode of action, how Bovaer works. This is something we clarified in 2015, published it in 2016. What I'm trying to say, it looks a bit complicated, but there is nothing weird. It's very clear how it works. It's highly specific. We understand the mode of action, and we made it public for academic researchers, for policymakers, and the public in general. When you feed Bovaer, you see this complicated drawing on the right-hand side. As soon as Bovaer does its job, the molecule falls apart into 2 natural fragments, which are shown on the left-hand side. And from there on, everything that's happening in the rumen is happening anyway, because these 2 fragments of the molecule are present in the feed of the animal. So nothing is unusual or strange there. So it's targeting a very specific enzyme. It temporarily inactivates this enzyme. So if you stop feeding Bovaer, there's a natural process that brings the activity back, and methane production in the cow gets back to its normal level. I mentioned it's cleaved into 2 natural fragments, and the specific mode of action is also one of the indication why we don't think on the long run you will see any adaptation. And we have finished several long-term trials, and we are adding a few more, also with the support of the Canadian research community, to prove this even further. So many studies have demonstrated the effect of Bovaer. There's one slide that shows the reduction in methane as a bar chart, and the green line indicates the 30% on average that we achieve. But you see a little bit the distribution. This is also a picture, a historical picture, because now we understand very clearly what drives the methane production and what's the interlink between the feed that you provide to the animals and the dosage of Bovaer. But you see very nicely, it works all the time. And this picture is then also replicated for beef cattle. In beef cattle, of course, you need to distinguish between backgrounding and finishing diet, because the diet is very much responsible for the baseline of the methane production. And on the backgrounding, we are in the 25–30% region of methane reduction. And in the finishing, we are higher, so 45–50. But you see on the very right-hand side that we also reached 80–90% methane reduction. Taking all these, and also a study in the Netherlands, where we said, how is the feed composition driving the methane production? And of course, the Netherlands is for the company DSM close to home, because we're headquartered in the Netherlands, and therefore we studied the feed composition in terms of silage and maize silage and grass silage, different compositions there. And the more roughage you have, the higher the methane production. And if you have more grass silage, then the methane reduction or the methane production is lower. And you see the numbers on the right-hand side, where a low and a medium dosage of Bovaer are reducing methane production. So with a higher grass silage, we reach 29 and 70% reduction. And when you move to a lower grass silage and higher maize silage with the same level of concentrate, the methane reduction in percentage is higher. Taking all these numbers together, we were scratching our hand and saying, how can we get into a situation where we can predict the effect of Bovaer and what's driving methane production? So since, strictly speaking, methane is not produced by the cow, but by the microorganism in the rumen, you could say the methane production is, and the activity and the number of these microorganisms is entirely driven by the feed of the animal. And therefore, we said, what dietary components is driving the methane production? And we went through all the trials, analyzed the data, and also put this in correlation to the dosage of Bovaer used. And we came up with this formula, which you see here. Long story short, the dosage is responsible of Bovaer. That's easy to understand. The more Bovaer you feed, the higher the methane reduction. But then the higher the NDF content, the lower the effect of Bovaer, and also the fat content has a small effect on the efficacy of Bovaer in terms of methane reduction. So we published this in the Journal of Dairy Science at the end of 2022. That's now also available for all people that are working with carbon crediting or carbon accounting tools. And now we are always making our prediction before we start a trial. And we can say that we are most of the time pretty spot on with the prediction of the methane reduction in relation to the dosage of Bovaer that we feed. And that's, of course, a great advantage. I mentioned at the beginning the effect of Bovaer is immediate, and this is shown on the left-hand side. You see on the time point 0 a feeding event where the control animals have no Bovaer in the feed and methane production goes up quite nicely. That's the normal pattern, and then returns to the original level. But when Bovaer is in the feed, you see within an hour, it really drops. That's the pulse dose. And if you don't have any Bovaer in the feed, after 3 hours, the methane production of the animal resumes. So the opposite, or the other picture that's complementary to this one, is shown on the right-hand side. Here you have the feeding event, but we are not looking into hours on the x-axis, but days in the study. And you see, if you feed constantly Bovaer, your methane production stays down. This experiment was done with growing animals. So the control animals are growing, producing more and more methane. And of course, this line is also reflected by the treated animals. Therefore, but as long as you have Bovaer in the feed, methane stays down. But what you also see is, as soon as you stop feeding Bovaer, methane production resumes very quickly up to its original level, which also means that we don't kill the microorganisms and don't do any bad things to the cow. We just reduce the activity of this so-called archaea. And if you stop feeding Bovaer, everything goes back to the normal level in a very short period of time, so 1 or 2 days. Good. I think, yeah. And then here on the performance parameter, this is, of course, after we saw it works for methane reduction, we turned into the question, does it have any effect on performance parameters or on edible products? And the short message is it does not have any negative effect on performance parameter. So that means the feed efficiency, daily gain, final weight is not affected. We did detailed studies for milk yield, milk composition, cheese production, and also rumen fermentation. That's all unchanged and sometimes even in a positive way. And there is no effect on the dairy and beef quality. So yogurt and cheese was tasted, was analyzed in all different aspects, also published. And also the meat was analyzed with sensory panels, and we didn't see any negative effect on these parameters. And then, of course, the effect on excreta, also large contribution from the Canadian research community. It has no effect on excreta, which is also, you don't find Bovaer in excreta because I showed you earlier it's getting destroyed by its own mode of action. But also the manure composition stays unchanged, which is important for people that are monetizing the manure, for example, in terms of biogas productions. So overall, there's a very positive, and as I said, we published all our results over the years, and it's all out there, and you can read the results. We can also share the publication list afterwards. How is Bovaer made? Very simple. So you see how it's made. So it starts from two natural products, nitrates or nitric acid, because you need this more reactive molecule. Nitric acid is out in nature. And we take this alcohol that you see here, which is out of a biofermentation. And then we do one synthesis step where we connect both molecules together. So it's not a mixture, it's really a new molecule. This is the molecule 3-NOP. And then we put this on the carrier material where we show the picture right away. And then you have this powder where we say a quarter of a teaspoon fed daily for a cow reduces methane by 30 to 50%. And I showed you at the beginning the mode of action. The mode of action is basically that while this molecule 3-NOP reduces methane, it gets cleaved back into its original fragments. So that's nice. And here you see the building blocks. The application of Bovaer, I mentioned in the beginning, it works in all feeding systems. So we have tested it in 100% grass-based systems, complex TMR system, and finishing beef cattle diet. It always works. You need to adapt the dose because the baseline of methane production in these feeding systems is different because the activity and the number of microorganisms is different. And the initial form that we are selling now as Bovaer 10 is this powder that you can mix in the feeds. And you can mix it in TMR for the dairy cows or in feedlot systems as shown on the picture below. What we have currently under investigation is to expand the application of Bovaer into grazing and backgrounding systems. And you see already here a picture where we show slow release forms, which means you feed Bovaer at one point of the day and the cow, or the form releases Bovaer over time and therefore has a long-lasting effect. So these are things that are currently under development. Good. And I think with this one, I'm handing back to Mark. Right?
Yep.
Good.
Good. So continuing here. So we spoke about, and Mike already mentioned 3-NOP and Bovaer 10, and just to get it all of us on the same page. So 3-NOP is the active ingredient. So if you read any of the scientific literature, it's typically presented as 3-NOP. What we sell is the commercial form, which is diluted. So that's diluted on silica to get a free-flowing powder. It's a 10% dilution, so therefore 10% active in that dilution. Therefore, we called it Bovaer 10. That's the form, the commercial form that will be available, is available in Canada. The approved dosage rate is different on the dairy and the beef cattle. So basically for dairy cattle, the ranges of 0.6 to 1 grams per kilo of dry matter intake. For the beef cattle, it's slightly higher. We quite often get the question, and where do you start, right? Where in this range? Well, of course, if you want to have the highest methane reduction, you start on the high end, but in all seriousness, most of the customers we work with globally start on the low end because they just want to get started with the product, understand what that indeed show that there's no impact in their production systems, right? Which of course we've known, but also because even if you look at the dairy cattle and you start with 0.6, you already have a 30% reduction in methane. That translates actually to a lowering of the dairy footprint of the total dairy footprint by 15%. So it's a very significant step change already. That's why also people start at the lower end of the range. And of course, there's always an economics and cost perspective to this as well. Yep. So then the question is, how do you get recognized and rewarded, right? Because Mike showed already, basically there's no impact on performance, which is good news that there's no negative impact on performance. The bad news, of course, is that there's no positive impact on performance either, right? So this is really something that is purely worked out and developed to reduce methane emissions. Now, methane emissions you cannot easily measure. So what we've done is that meta-analysis, which Mike has shown already, that meta-analysis actually goes into various carbon accounting tools, right? So some more international ones is the Cool Farm tool, but you also have regional ones and others. So we basically provide that equation. Sometimes it gets adapted or tweaked a little bit locally, but that's then the starting point. And what you then need to demonstrate is, has the product been used? Now, typically Bovaer can either, in the very large feedlots, of course, can go through a micro machine, but in the smaller operations, you typically include this in a mineral blend or a mineral vitamin mix. So what you then need to keep, of course, is a copy of the invoice. You can demonstrate that the product thereby has been used. You apply the algorithm, or the algorithm gets applied, and then you get the number of tons of CO2 saved. And just to put that in perspective, in Canadian dairy system, you probably save close to 1.5 ton per cow per year. So that's a very significant change already. So it's that tooling that's being set up. Then basically we support footprinting tools of our customers. So we typically work with dairy processors or beef processors, ask them, hey, what is it that you use as a tool today? How do you measure the rest of your footprint? And we then work with them to see how to include the algorithm in the tool, whether that's easy fix or whether they need some adaptations. Here's just some of the examples that we have worked with and where it's now included, mostly, of course, European dairy companies or European systems, because that's where we had the first approvals in. In certain cases, we also provide an app ourselves. So we have noticed that in some of our customers are struggling to really keep that evidence and the burden of proof traced at the farm level. So we have an app which we call Good Moves, which allows you basically to take a picture of your invoice, upload that as proof, and with the filling in a few metrics and your ownership, you see how many tons of CO2 have been saved. This is then also could directly be traced and tracked back to or allocated to your processor, or in certain cases, the supermarket chain. This is all linked to what is required either for the processor or the supermarket chain, right? So this is not for the individual farmer to initiate. They would not be, it's not linked to a carbon marketplace or anything like this. This is really for increasing the transparency in the chain if required, if the current LCA tools that are applied are not fit for purpose yet. Like Mike also showed quite a few logos of companies we work with. Just want to mention a few examples here, not go through the small font. I think that's important as well. What we typically see is that companies start with announcing a pilot. see how does this work in my system, but I think even more important, and how do I keep track of the reductions? How do I keep track of the relevant information? How do I, in essence, build my business model and business system around this? Second piece that we see, so that on the far right side, is companies starting to include it in their sustainability reports, really showing, hey, we recognize the challenges that there are with methane. We are working on trying to reduce our footprint. One of the examples is using Bovaer. We've also seen a number of companies that are using this in the consumer marketing more towards, I have a lower carbon footprint product these days. So that's what, for example, Danone started with in Belgium. There's one, so most of these companies here on the page are dairy companies, with the exception of the one on the right, which is a beef company, is Nepco, and the one in the middle, Coles. So Coles is actually a supermarket chain, which has launched a carbon neutral beef line in Australia, started that in some of the major cities. It now went nationwide, and one of the tools, because of course you need to do much more than just use Bovaer, but one of the tools they use is Bovaer in that piece. And Coles pays the feedlot operators for the use of Bovaer. And that's, I think, the most common model. It's actually the processor and the retailer, or sometimes the food service companies, that play a role in actually the incentivization and the payment for Bovaer. Where are we now all available? So today we are in 58 countries. In essence, most of Latin America, all of Europe, now also including Canada, and we hope to get a number of Asian markets added fairly soon, particularly Japan and Korea and India. The US, we are working with Elanco. So Elanco is our licensed partner responsible for the sales, registration, sales, and marketing in the US only. They are expect and anticipate market approval somewhere in the first half of this year, right? So you're just ahead in that sense. And then, as indicated by Alex at the beginning, these are the context people in case you have specific questions. So my Canadian colleagues, specifically, of course, if it comes to quotations or follow-ups, when can we get the product delivered and such, that's their email contacts. My own one, if you want to have a bit more of a global perspective or understand what's happening, particularly on monetization and such, and Mike for any scientific and related questions, of course. And if there's any other questions, we also have a general email address, which we're very happy to get your questions, respond to them, and help you get started or move forward. And with that, the formal part of the presentation is finished, and we'll go to some of the Q&A.
Wonderful. We do have several questions. We'll start with the first one, which is several questions in one. Mark, so I'll give this one to you. So I'm hearing from producers and nutritional consultants several questions. What does Bovaer cost? So that would be per gram or per head per day for feed lot cattle in Canada. So cost, right? How can I get it? Where can I get it? Who can I get it? And when will it be available? All the practical things, right, of getting and buying a product.
Good. And Alex, if I forget to answer one of those 5 sub-questions, please remind me again. Hey, let me get started with the product is currently being shipped towards Canada, so it should be in Canada within the next month. How do you get, or where would it be available? It's available then at dsm-firmenich, who will make it available through the different feed mills or as well. So that's where you can order. So if you're a feed miller today, or if you're somebody that mixes vitamin or mineral mixes, it's basically contact your DSM rep, who you have seen on the previous page. If you are a farmer or a potential user of the product, basically go to your supplier and ask them. And if they don't know, we're happy to help there, of course, as well. So that's the how can you get it, which is in essence through your regular channel, right? So there's no special channels. It's just through your regular channel. That's how you can order it. And what does Bovaer cost? That's a very difficult or complicated question, because it, of course, depends on how big is your operations and how long is your supply agreement and many other factors, but I think you should think, depending on whether it's feedlot or dairy, whether it's cows that have a high dry matter intake or a low one, you should think somewhere in the range between 35 and 45 Canadian cents per head and day. But again, that fully depends on, it could be a bit outside of that range as well, depending on your individual situation, and we're very happy to calculate that through as a follow-up question.
Really, if they're not really sure, probably our Canada colleagues, right, will be a good place to start and get more direction.
Exactly.
All right, this question is for Mike. So Mike, based on the slide 14, it seems that it's better to include Bovaer in the TMR. For example, continuous supply of the additive in the rumen than as a premix. Can you please confirm?
Yeah, that's correct. If you have it mixed in the premix, which goes then in the TMR, that's the way how we supply it, usually also in the trials. Then you guarantee that with every bite the cow gets the feed produces methane, and then Bovaer is there, the active ingredient. That's the trick, right? And therefore, if you have it in the feed, that's the best way. And therefore, we are also working on what I showed on the slow release form, where you simulate the same situation, just making this bite out in the grazing system independent from the Bovaer intake.
So what about the stability of Bovaer, Mike, when stored or after being mixed with the feed?
Yeah, so we have finished an extensive series of stability testing, right? So we can state a few things. So Bovaer is, as a molecule, rock stable, except when you mix it with iron 2 salts. So iron 2, not iron in itself, but iron in the oxidation state +2 is not good. Anything else is not touching Bovaer. The other one is Bovaer is a small, or the active ingredient Bovaer is 3-NOP is a small molecule, right? And therefore, we looked also into this stability, but we can state that it's stable in the application that we are foreseeing today.
Yeah, maybe to add to that, if I may. So the product has today a shelf life of in the bag that we delivered of 3 years. And when mixed in the typical premixes, the typical shelf lives that are currently applicable for the premixes itself are working there as well, as long as we exclude the iron 2 salts, as Mike said.
What about the effective feed, TMR delivery, on the efficacy of Bovaer? For example, feeding it one amount or double the amount versus double the amount.
Yes, so I think the way I read the question, but happy to be corrected, is basically what happens if you mix it, if you prepare your feed once a day or twice a day. At the end of the day, that doesn't matter. So
doesn't matter.
As long as it's in the feed in every single bite, that's the key piece, right? So don't mix it in part of your mixture and not in the other part. But whether you prepare your feed once a day and it's out in the bunk for the cow the whole day, or whether you produce this twice a day or 3 times a day in certain feedlot operations, it's all the same, right?
Yes.
So just needs to be in every bite. But clearly, if you prepare the feed once in the day, the product will still be there in the evening time. So that's not an issue whatsoever.
Exactly.
Okay, Mark, can you clarify if there's an active pathway today to monetize the Bovaer data in Canada using your calculator or any other tool that you discussed?
So we are working with a number of processors and potential other buyers of dairy and also beef, to see what their interest is and how much they would be willing to buy and basically procure. And this is still in the early stages. At the end of the day, we received market approval less than a month ago. So give us a little bit of time, but I do expect some news soon. And as you can imagine, some of those global customers that we shared, like a Danone or Nestle or others, of course, have operations in Canada as well, and we'll be looking at what can they do also in Canada.
Okay, kind of a different question here. Has dsm-firmenich done public perception research in Canada or North America to determine consumer sentiment on the usage of Bovaer?
Yes, so we've done work. We actually started in the US, thinking that's where some of the most critical consumers are. I mean, if you open up a menu, you have no this, no this, no this, no this, and finally on page 2, you find the food items, right? So that's where we started with actually some of the message testing and message design specifically related to Bovaer. Then went to do the same work in New Zealand, where everybody believes their cows are on green grass the whole day through, right? So it's a very different perception. And if you then add something to feed, how would people react? And the third one was actually in the Netherlands, where we also worked on consumer perception work. What's clear is, and all of them were, I think the general message is they're very positive, particularly if people link it to what's the impact being generated. So if you say, well, hey, with a very small step of buying a milk which has been used with Bovaer, or which is more sustainable, you actually can have a direct impact on the footprint, and particularly given that the methane goes down, people are quite positive, right? If you would ask the question, well, hey, it's a chemically produced additive, should you think that this should be added to your milk? I can already tell you what the answer is. People don't like it that way. But I think it's really there for how do you also message it. And overall, it's been well accepted. It's being used. And if you look also across Europe, where many of the big dairy companies have made announcements of that they are using the product, it's very well received and appreciated that those companies make a big change on their footprint.
Okay, so what is the suggested nomenclature to use in Canada when you describe Bovaer, right? With the press release, it was called a feed ingredient, but when you look at other countries like Australia, it's a dietary supplement, and then it's in other countries, it's a feed additive.
Yeah, so this is regulatory driven, so it's in the category of feed ingredients, so cannot change that, unfortunately. In certain geographies, indeed, it's a feed additive. You could also call it a feed supplement in some of those markets, but that's related to the regulatory category rather than what we would like or might like.
So feed ingredient in Canada then.
Yeah.
In one of the graphs shown, after roughly 3 hours of not feeding Bovaer, the methane production returned to a baseline. Thinking of the up to 82% reduction in methane figure that you observed in North America, is this a holistic view whereby you take into account methane production during the night, whereby the impact of Bovaer has worn off?
So the way we are measuring this and also communicated this is we are measuring this against control animals, and it's on a full 24 hours timeline, right? So therefore, if you do this pulse dosing and you see this sharp drop to almost zero and then returning, we don't report this the maximum there, but we always stretch it to the 24-hour for the full day. And therefore, the 82% or 90%, the higher numbers as well as the lower numbers that were against control animals and over 24 hours the full day.
And I think to add to that and building on that slide, in that slide, we basically showed what happens rather than Bovaer having been included in every bite. What happens if you basically feed all the Bovaer first and then thereafter start providing the rest of the ration throughout the next 24 hours. And that's where you then get a very steep impact and reduction of somewhere 80 or 90% for a relatively short time. Now, if you would do this, of course, you feed it on a continuous basis, right? So it's mixed in TMR, or it's mixed in the feed bank for the beef animals. You see a much less steep drop, but a much more consistent drop, because that's basically when it acts continuously.
Have there been any trials in combination with rumensin or yeast? Is there a higher reduction of methane cost per head per day, a vet script, or not in Canada?
So the answer is yes, we have tested this. It's also publicly available, so it's published, and there is an additive effect. And of course, that's one of the most frequent questions we get in the last 18 months or 2 years, combination product testing, all kinds, right? And we are testing a lot. Sometimes we see an additive effect. We also have cases where we see a synergistic effect, and it will be also published, so where the combination is even reducing methane higher. And with monensin tested in Canada, you see an additive effect, a small additive effect.
Well, I think, yeah, we see in certain cases even a small synergetic effect, but it's at least additive. I think that's the
Yes.
key piece there. So I think we've tested it in essence in all common dietary components, and in certain regions that indeed includes rumensin.
So there's one slide showing methane reduction with inclusion of the product. It does seem to show a trend of increasing methane over the 4-month period. Does a rumen adapt to the product over time, and could we expect less methane reduction over the lactation cycle?
So the slide was, and I hope I mentioned it during my presentation, the slide contained two elements. One is this long-term effect, and it was done with growing animals, and growing animals are producing, while their growth period, more and more methane, right? And therefore the control animal went up, and in parallel the treated animals. But we have long-term studies. There is no indication that we are facing adaptation.
Exactly. So I think as you, of course, go through the growing cattle, they eat more, and more eating means more methane, right? So that's why you see both of them go up from that perspective.
Yes.
So for researchers, will there be any restrictions in the use of Bovaer for research purposes once the product, well, now that it's available in Canada?
I'm not sure what research restrictions you're talking about. At the end of the day, if you use it within the approvals of CFIA, of course, there's no restrictions, right? If you now say, well, let me test it at half the dose or 10 times the dose, then there probably will be relevant research permits required and animal welfare, depending on what the university requirements are, etc. But if you are within the approved dose, I don't see that there's any limitations.
Maybe I can add one comment, because we just got a request yesterday. We have this tradition that we support research activities in this field with our knowledge. And why I'm saying this, we have accumulated 15 years of research knowledge, and sometimes things can go wrong and then you're disappointed, but we have a long list accumulated. What are the watch outs? What should you do in order to make this a successful trial? And we offer to the research community sharing our knowledge. Also in people can contact us. Although we published everything, we are quite aware that people are not looking forward to read. We have 74 publications out. That's a lot of paper to read. It might be easier to get us a message in a call and have a chat with us. We are happy to share and support these activities.
So this person apologizes in case they missed it during the presentation, but they would like for you to clarify again, what is produced instead of methane while you feed Bovaer?
Yeah, that's also, yeah. So instead might not be the right wording, because the rumen microbiome is a dynamic system, right? If you change the feed of the animal, the microbiome will digest this new feed as well as the old feed, but we will regroup and digest it in a different way. So what we see is when you feed Bovaer, you reduce methane, and then there is microbial regrouping to digest the feed in the normal way. So there is not more CO2 produced, and we have data, and they are also published. What we see is part of the volatile fatty acids profile changes for the benefit of the cow. In almost every trial, or can maybe state in every trial, you see that more propionate is produced and less acetate, more energy available for the cow. Hydrogen gets redirected to a certain extent, and that's a hot research topic that we are also following with an international community to clarify all these details on hydrogen pathways, hydrogen production and consumption pathways. So the short answer is there is nothing produced instead. The metabolism is regrouping and is working as normal as before.
So very similar question, right? What happens to the hydrogen molecules in the rumen if there is less methane to remove them?
So what we see is there is a bit of a hydrogen increase that we can measure. But when you do the full math, this is only accounting for 10 to 20%. So 80 to 90% of the hydrogen is redirected in the rumen, and we are trying to find out what exactly happens and what are the driving force. Some people think that the methane biochemistry and developing an inhibitor for methane is a complicated story. But when you look into hydrogen and the molecular biology that's associated with the hydrogen ecosystem in the rumen, that's even more complex. But the international community is now looking in detail into this question. And we hope in a not too distant future to be able to clarify this question with the respective scientific publications.
In Alberta, we have a regulated carbon market that has specific approved protocols for quantifying carbon reduction and generating regulated carbon offsets. Given the very large percentage of Canadian fed cattle are in Alberta, have you been working with Alberta's government tier program regulators as you develop your algorithm?
Yeah, so we both at the federal level, where there currently is the REMI protocol being discussed, as well as, of course, in Alberta with the fed cattle protocol and other protocols being under discussion. We have engaged prior to market approval, right, to at least create some awareness. At that moment, they couldn't include it yet because they say, well, what happens if we do all the work and the product doesn't get approved or gets approved only in a much later date? So now that we have the market approval, we are indeed actively working and exploring with both at the Alberta level, but also at the federal level, how to create the opportunities on the carbon credit market in those respective regions. That's mostly beef driven. Of course, the same applies for dairy, where we're looking also in the voluntary market. Are there opportunities? What we've seen just globally, and that picks up on one of the other questions, well, what if there's no financial benefit I see at the farm, no productivity benefit, who's going to pay for it? How am I going to make money out of this? Globally seen, I would say 90% or even 95% of the demand that we have actually comes from within the value chain. It's the processors and the retailers that are paying for the product and making it available inside the chain, so that there's also no burden for the farmers or the feedlot operators. There's one or two exemptions where we actually work with carbon credit agencies and explore how to monetize these. And then, of course, the Alberta and the federal markets could be additional opportunities. But what is typically happening is, given that the methane needs to be reduced, given that with something called the Science-Based Target Initiative, you actually need to reduce within your own value chain, we see more and more that the reductions stay inside the chain rather than that they move outside. So that's where the current focus from a business development opportunity is in. But happy always to discuss other models and other ideas, because we fully agree that it needs to be at least cost neutral at the farm level to make any sense for a farmer to use the product.
So speaking of milk composition, you said that you took samples of yogurt and cheese. What about butter? Was there any analysis on the texture of butter?
Yes, it was just published a month ago, and it is not included in the slide deck, but we have a beautiful slide on the butter analysis. And so on the texture of the butter, there is even no effect, right? And the positive thing is the stability against oxidation of fatty acids has been discovered to improve. So one parameter on butter is even improving for Bovaer fat cows. And all in all, the butter stays from a process stability perspective unchanged. And we can share maybe the publication list, but it has been published, I think, a month ago. So it's available to everybody.
So when working with the control group and the Bovaer group, did you notice any difference in the manure composition? Did it dramatically change the nutrients within the manure that would change its ability to be used as a fertilizer?
So here also the answer is not at all. So it stays unchanged, the manure, as I said, and it can be used in the bioreactors afterwards. And Karen Bushman and her team and postdoc, they even went through the effort to compost the manure, put it on the fields, and then compare the growing of different crops, and also found no difference. So that's good news. And when you analyze the manure, there is no trace of Bovaer in there, which is also easy to explain because, as I said, Bovaer gets destroyed or cleaved by its own mode of action, so you don't find it back in the excreta.
Yeah, maybe to add there, we have now, of course, in several hundreds of farms are using the product already. In Europe and elsewhere, many of them have digesters. We've only had one complaint, and actually, when you then look at it, we went into the deep dive in it. Basically, they said, well, hey, as of March, our digester has been producing less. And we then went back to the farm records, and there was no Bovaer until actually mid-April on the farm. So this has absolutely nothing to do with Bovaer. And that was also proven thereafter. So yes, you always get questions. We're happy to look into the details together with anybody. But thus far, neither from the research side, as Mike shared, nor from the practical feedback that we're hearing, have there been any indications that there would be any effect whatsoever on the manure, and particularly on the digester.
Would Bovaer need a prescription for a vet? Is there going to be any sort of prescription involved?
I'm not sure what we mean from a prescription perspective in this case.
Like a veterinary drug, probably.
Correct.
Nope. So it's just like any other feed ingredient that you can buy as such.
No prescription.
Have you noticed any difference in efficacy and delivery method, specifically using a micro machine versus a premix mineral?
No, we also went through the micro machine exercise, and we were quite happy what we saw there, right? Really quite happy in terms of homogeneity of the feeds and the recovery rate of Bovaer. So no difference, and micro machines worked very well.
Have you noticed any difference? Oh no, sorry, asked it. Are there any potential consequences associated with overfeeding Bovaer? For example, if a cow's mistakenly fed Bovaer beyond the permitted requirements?
No, so actually, we need to show, when you register a product, you also need to do something that's called a tolerance study. And in the tolerance study, you need to show that what happens if you overfeed with a certain multiple. And then you need to show non-inferiority. So you actually need to show that there's absolutely no effect on the performance of the animal for it to get the clearance, right? So therefore, as part of our registration dossier, we actually show that even if you overfeed at a certain multiple, there's no effect. Now, I think overfeeding is actually quite difficult, because if it's already mixed in your feed mix and it's a homogeneously spread throughout the feed, the cow will just get a bite, right? So it's very unlikely that it would all be in one place or one location. So from a practical perspective, it's highly unlikely, but even if there would have been some error being made, again, there's we have no indications that there would be a significant effect.
Okay, and we're getting up to that hour, so I'm going to ask one more question, and then if we don't get to answer any of the questions, we will certainly follow up on these questions to make sure you get the answers. But last question, is there any absorption of the molecule in ruminants?
So this has also been tested by a so-called ADME study in detail, right? And therefore, so the molecule gets into the rumen, works, and then the cleavage products, they go into their normal biochemistry pathway for the individual fragments that's known for 30, 40 years. We have done all the blood analysis, all the meat analysis, and you don't find Bovaer in the edible product and in the animal later on.
Wonderful. Thank you so much for the level of participation from our entire audience. Keep the questions coming. If you didn't get a chance, like I said, we will follow up and make sure you get your answers. Also, in the discussions, you're going to see a link where you can download the deck. So all the slides from today will be available to you via PDF. And then you can also download some brochures in both English and French with some higher level messaging with the key values that Bovaer delivers. That way you can share them with your colleagues or others interested in learning more about the product. But with that, Mark, Mike, thank you so much.
Thank you
for the presentation and for answering all of these questions. And thank you for participating in today's webinar.
You're welcome.
Thank you. Bye-bye.
Thank you.
Goodbye, everybody. Bye-bye.